One of the more powerful features of object-oriented programming is the ability to inherit one class from another. The idea is you start with a general base class that defines the basic functionality of that entity type, and then you create more specific derivatives of that type. In our case, we're going to take a look at the person class, and we're going to use person as our base class. So this is going to establish a hierarchy where we start with a person and then we derive to more specific types of person objects. So this class person will have a class variable called person count, which we will increment every time we create a new person object. Here is the constructor we're going to use. We have the standard parameters ID, first name, last name, and we set them here as instance variables. And then we have a print greeting method, which is simply going to say hello to the first and last name. We have our str method or str method, which is going to be the string representation of this object, and then a method called header, which is a member of the person class itself and not a specific instance, and you can tell that because there is no self parameter. And this is going to print out some static label that says ID, last name, and first name. And if you look at the alignments in both the str and the header methods, you'll see that these will line up nicely. So we can use this header method as literally the header for when we print out a series of person objects. Now, I didn't go to the bother of creating properties for the internal variables here, ID, first name, and last name, just to keep the example as simple and understandable as possible. But by all means, for real implementation, this would most likely involve properties, especially for ID, where we may want to restrict it to read-only access once it's created. We don't want to change the IDs of people because that may actually represent a primary key in a database table. Likewise, we may want to use properties to make sure that first and last name are not empty. Okay, enough about person. We're going to create a new cell here, and we are going to introduce a new class called employee. Now, employee is going to be derived from person. So we are going to put person inside the parentheses of the class's definition of employee. So this tells us right away that employee is based on the person class, and therefore it will have access to all of the members of person, and then we can extend the definition of this class to include new values that are specific to an employee, not just every person. So the first thing we want to do is decide what the extra values and methods are going to be for this particular employee class. I think the one thing we need to add is salary. So the simplest thing we could do is create our init, not int, init method, and it will again have a self, an ID, a first name, a last name, and then I'll add salary. And the first thing we're going to do is initialize the base class person with values that were passed in to this constructor, specifically the ID, first name, and last name. So to do that, I use the keyword super, which refers to the base class or superclass, and then we will call its init method, and we'll pass it ID, first name, and last name. So I'll put a comment here what this is doing. We are calling the base class constructor or initializer. Then we can set the values that are specific to employee. as such. Now let's look at this in a little more detail so you can understand what's going on. So this super method is a special method that provides us access to whatever the type is defined in the parentheses here. So that refers to the person superclass. Notice here the constructor is written very much the same way as the base class, and I do that on purpose. That way when I call the constructor of one or the other, the parameters will line up one for one except for all of the newer ones for employee, which are at the end. It is by no means necessary to do it this way. It's just for me. It helps me keep things organized well, both in the structure of the code and being able to remember how to call these objects. So when I call the constructor of the base class, the parameters will be in very much the same order. Also note, I don't have to pass self as an argument here. It is implied because this init is an instance member of the superclass. Then I simply add all of the properties or variables that are necessary for this new derivation, this employee version of a person. Let's also do something called overriding or shadowing the str method of the base class. So when we print the string for these classes, we will actually get the specific version for that particular data type. So let's go ahead and define str, and notice here I could repeat all of this, and that's perfectly acceptable. And then I could add self.salary, and we will format it right justified 12 places, and then 0.2f because it is a currency value, so I want 2 decimal places. And then I could also define the header by adding to it the salary label, and we'll also right justify that 12 so they'll match. So let's run these two classes and make sure that Python is happy with them. And let's go ahead and create a few of these. So we'll create a person, the ID, and then we have our first name and last name. Let's do Bobby Jones, and then we'll print just to show that we have a new person. And then let's create another object, and this time it'll be of type employee. And we will do, let's do Janie Williams, and there's her salary. And then we'll print person count again. Let's go ahead and run this. You can see here we've created person 1 and employee 1, and the person count is 2. Let's go ahead and print P1, and let's print E1. You can see here are our 2 people. Notice when I print P1, I don't have a salary, but when I print E1, I do have a salary. But we have this neat little header thing that we can call. So if we have a group of person or employee objects, we can print the appropriate header. Although because the employee's header is very similar and it's going to line up nicely with the person header, we can just print the employee's header. try that again. You can see it lines up, and it's just the person doesn't have a salary, and that's fine. But we need to take a look at this in a little more detail because I kind of glossed over some of the important features here. What happens if I were to get rid of the STR of employee? Okay, so I will comment that out. So STR no longer exists inside employee. Let's rerun the code. So I'm going to restart the kernel just so we don't have the person counter growing. So I again have two person objects. Let's run this and print it. Well, the interesting thing is when I print E1 this time, we wouldn't expect to ever see salary again because it's gone. We do not have an STR function that shows salary. But notice it fell back on person's STR. So we get the ID, last name, and first name. So it is functioning well as far as the inheritance is concerned. There's a hierarchy here. So when we call the STR method of employee 1 here, or E1, it's going to search its object to see if that method exists. If it doesn't, it's going to fall back to the next logical choice, which is of person. Well, the one thing that we glossed over at the very beginning is that person also inherits from another data type, which is actually object. If I were to rerun this code, I'm not going to have any difference here because the object derivation is implied if you don't provide something in these parentheses. That's why when I get rid of the STR of person and I rerun all of this, now it defaults to what object will show when you do STR, which is a description of the object itself. In this case, it's saying it is a person object at this address or an employee object at this address. Likewise, if I were to return employees' definition of STR but not persons, and I'll rerun all the code, you'll see that employee will still be able to show all of the details of the employee that we defined in STR, but we don't get that from person now. And again, it's because when you call the STR method, which again, it's implied when you say print, for P1, it's going to jump right to the person class. It's going to see we don't have STR defined, so then it has to fall back on object's definition, which again is just going to print the name of the object and the address where it's stored in memory. So let's go ahead and put this back in so they both have an STR. And you can see we now have properly overridden the STR method for all of our classes, both employee and person, and then obviously STR is being defined in object as well because we saw that it was doing something when we removed STR from our classes. So we're not really utilizing our base class in the best possible way. Because of the repetition that you see here in the STR method, you can see it's repeated exactly what was in the person's STR. We can make use of our base class within this STR method of employee, so we can replace that whole chunk of code with a call, and you might have guessed what this is going to be, to super dot str. And likewise, we can replace the first chunk of the header with a call to the person header method. Let's rerun it, and hopefully the output will be identical, and it is. So this is providing us a lot more reuse of our classes that we've defined than what we had previously. What about another type of person? How about we create another class, and this time we'll call it student. And again, it's going to derive from person. And rather than rewrite everything, I'm just going to copy everything from employee, and we'll start with this as our basis. So we have our student derives from person. It has a first name, last name, but instead of a salary, maybe we'll have a GPA. And so I'll replace salary with GPA, and then we'll say salary, instead of salary, we'll say GPA here as well. GPA doesn't need to be quite as large, so let's make it 7. And 2 decimal places for GPA is probably okay. Maybe we'll make it 3. And then we'll put GPA here for our label for the header. And again, we'll change this to 7. And let's create a student. And the student will have an ID. We'll have a first name, a last name, and then a GPA. Then we can print the student header. And then we can print the student object itself. Oop. My Java took over there for a second, and I put the data type in front of S1. Okay, so we have our new student object with an ID, a last name, first name, GPA. GPA does not need a $sign, does it? So let's go ahead and remove that. There we go, now it lines up. But one thing I noticed now, by seeing that $sign, salary doesn't exactly line up with the salary amount here that's being printed, and that's because the $sign physically takes up a space. So let's put another space here in the header to make room for that. So let's rerun all that. There, that's better. So now salary lines up. Don't need to be quite the perfectionist, but it is nice to fix things as you see them when you're going through your code, especially something that might later on cause problems, especially if we created yet another derivative of one of our classes. And as a matter of fact, we're going to do that right now. We'll have a class, and this time we're going to call it supervisor. And supervisor is going to derive from employee. So now you can see we have multiple derivations. We start with object with person. So person derives from object, employee derives from person, and then supervisor will derive from employee. And I'm going to copy employee's information one more time for this class. And besides a salary, we also, maybe we need something else for a supervisor, like let's give them a title. Okay, I can't think of anything better right now. This time, the super class that is calling for init is not person. It's going to be employees. So then I need to pass to call the employee constructor. If you take a look at it, the employee constructor requires ID, first name, last name, and salary. So this is known as basically calling down the constructor chain. So we have our salary now that we're calling in the base class constructor. So when this thing is being built, it calls this constructor init, which then calls the init of employee, which then in turn calls the init of person. And believe it or not, it's implied here that we're also going to be calling the init of object. If you don't supply it, it's done for you automatically behind the scenes. So instead of setting salary now, we're going to set the title as such. And we don't need to supply salary anymore in our str or our header because that will be taken care of by employee this time. Now, one thing we may want to do is change how we put in the title before we're adding things to the end of the string. Let's say we want to have our title at the beginning. So then we could put the title right here where we say self.title, and then we need to supply some kind of justification here or size. Let's say the title is 20 characters, and then we need to say title here. We're going to literally say title, just like we did here. Oh, I used the wrong kind of quotes. And we still need to specify that it's left justified 20. I think I got everything under control. So let's say S1 is equal to supervisor. And that will not work because of the capital U. And then we'll give the supervisor an ID. And then we need a first name, a last name. We need a salary. And finally, we need a title, the boss. And we can print supervisor dot header. And then finally, S1. Now, assuming everything went well, you'll see now title is up front. Then we have the ID, last name, first name, salary. Now, of course, we don't have to utilize the header of the base class or the str of the base class if we have significantly changed this class enough to where we need complete control over how the output's going to look. We could always add a completely new str utilizing all of the members of supervisor, which includes the members of employee and includes the members of person. But note here, supervisor has really no relation to a person. Or to a student, sorry. So supervisor and student are related just by the fact that they have a common ancestor of person. But a student can never be treated as a type of supervisor or vice versa. But they could all be treated as a type of person. Now, what I'm talking about here is when we start grouping these things together, we can treat all of these as a person object. What I mean by that is, let's go ahead and create another method in here called, actually, we don't need to. We already have one, which I completely forgot about, called print greeting. We have all of these objects now. We have a person one, and we can do the print greeting. And then we have our employee one. We have our student. And I just noticed something. Student and supervisor are using the same variables. So let's go ahead and we'll make the supervisor V1, for lack of a better one. So finally we'll do this with V1. Now I'm going to start running from the beginning because I destroyed our student object in the process of creating a supervisor. So we get all of our person objects. There's student. And then we're going to create our supervisor. And you can see here, it says the same thing every time. Why is it saying, say hello, first name, last name? Okay, very good. Oh, I just noticed something here. I'm saying print greeting. Print greeting already does the print, which is why I'm getting the nones. So what I can do here is I can just group select all of that, and I'm holding down the Alt key so I can select columns at a time, and then I'll rerun this. That's better. So you can see they each say hello, the name, hello, the name, hello, the name, hello, the name. So because the person class contains that print greeting method, all of our derivations will also have that method. And just like with str, if I wanted to change the greeting for one of them, I could in that specific class. So I could change print greeting in our supervisor class to say this instead. I could say, we're going to say hello, and then we could put the title in here. And then we'll put the first and last name. Now I could have been tricky and did some string replacement, but to inject, it would be first name, not fist name, and then last name, and then a period. So now when I, oops, what did I miss? Print greeting. Oh, I said del. How about death? Okay. And I also forgot to put the self. Okay. So now when I do print greeting, it's specific for supervisor because I changed what it looks like just for supervisor, but that's the only one that prints up the title as well. If we wanted to, we could change students print greeting to say, hello, Jack Ryan with a GPA of 3.875. We could do whatever we need that's specific to student. But the one thing I've done now is I've guaranteed that every one of our person-derived objects will also always have a print greeting method. And that is one of the beauties of inheritance, is we can start with a very general class and get more specific as we need to for different data types. Now, speaking of data types, we have all of these objects, and let's say we stuck them all in an array, okay, or a list. So we could say list is equal to, and then we'll put them in here. We'll say P1, E1, S1, and V1. So that should give us our list. Let's see what happens when we print the list. Okay, so we have all of our objects. It's a person, employee, a student, and a supervisor. Great. Okay, so what happens now instead of doing print list if we were to say for P in list, so for person in list, print P. Now that's more like what we were expecting to see. Notice that our supervisor does not line up well with the other data types, and that's okay because we had something specific for supervisor that we wanted to do. But as you can see here, we can treat all of these objects very similarly because they're all person objects. But what if we needed to know if a specific value in this list is a particular data type? Well, that's where we have the is operator, which is going to be extremely useful. Okay, so if we wanted to see if an object is of a specific data type, we could say if type of P1 is person, that should return true or false. So is P1 a person? It is a person. Now, this is going to tell us whether or not is an object is a specific type, but it will not tell us if it's derived from that type. So if I do E1 is person, that will return false because it is not a person specifically, it is an employee. Now this kind of goes contrary to the has a and is a relationship that all object-oriented programming languages basically share. Yes, employee 1 is a person, but the way the operator is being used in this language, this is going to give us whether or not it is that specific data type, not a derivation. Likewise, if I said is object, both of these will return false because they are not specifically objects. They are person and employee. Okay, so I'll put them back to person. So what happens if I want to know if a particular object actually derives from a data type? So we want to know if, for instance, a supervisor is a person, which it really is. Then instead of using type and is, we're going to use the isInstance method, and we're going to pass the object we wish to test and the class that we wish to test it against. So we can say, is instance P1 a person? Is instance E1 a person? And you'll see they're both true. And I'll also show you that the converse is not necessarily true. If we say employee this time, P1 is definitely not an employee, but E1 is. So you can see P1 is not an employee, but E1 is. Likewise, if we were to ask is instance, and we're going to see if V1, the supervisor, is also a type of an employee, you'll see it is true. But it is also a person, and it's also an object. So you can see these are all true. But is it a student? And the answer should be no, because it's not in the same inheritance chain. So we have object at the top, then we have a next layer where it's person, and then person kind of splits into two. We have employee, and then we have student. And then we can continue down the employee branch and get supervisor. So this is a really powerful technique, being able to create derivatives of our classes. So we have subclasses, superclasses, or a whole bunch of different names that we can use. And just real quick, so person is the superclass of employee. Employee is a subclass of person. We could also say that person is a base class, employee is a derivative. There are other terminologies out there that you can also adopt, but calling them that, one or the other, either saying super and subclass or base and derived class, that's the most common terminology you will run across. And I also mentioned this has a and is a relationship, and a lot of times it'll pop up on employment tests just to see whether or not you actually understand the concept of object-oriented programming. And I'll put it real simple. If a class derives from another, then that derivative is a base class. So employee is a person. But employee has a salary. It is not a salary. So the has a relationship is just containment. The employee contains a salary. Person contains an ID, a first name and last name. However, employee is not a salary. It is a person. Person is not a first name and last name. It is an object, because that's what it derives from. So that's really the difference between has a and is a relationship. Has is specifically just for containment purposes. What data does that object contain? Whereas the is a relationship is talking about how it came into being. Does it derive from another class? And that right there should give you enough information to be able to understand the differences. And likewise, I said, this is operator tends to be used in a lot of languages to indicate whether or not a particular object derives from another type. In this case, in Python, that's not the case. So if you want to see if it is an instance of another data type, you have to use the is instance, and then you can test it for, like I said, for supervisor, from object, person, employee. It's also supervisor. Let me put that in here because I missed that. So we have supervisor, employee, person, object, but it is not a student.